Hey, all you cool cats and kittens. Today we're going to talk about absolute convergence, conditional convergence, and the ratio test. So before we jump into all of that, let's just quickly remind ourselves of what we've been talking about so far in class regarding series sequence or series convergence and divergence. So some of the major points from the last couple classes were that we are still asking this question of, hey, we're handed some infinite series, say from n equals 1 to infinity, and we're wondering whether or not this series equals some finite number and converges, or if this series diverges. And the two major broad tests that we had were the so-called comparison tests or the integral tests. And these could be applied to a broad range of series. The series didn't have to have a particular form in general, but it needed to have positive terms. So all of these series we considered applying the comparison test to or the integral test all had to have positive terms only. This brought up the next interesting question for us. Well, what happens if we have a series that doesn't have strictly positive terms being added together? And the first series test we talked about was the alternating series test. And what was special about this test was we could only apply it to series which alternate in sign, clever enough by the name. And that's a series where we have this alternation of plus minus, plus minus, plus minus kind of pattern going on forever. And well, that's all well and good, but there's going to be series in which have negative terms, but in which the terms do not alternate in sign. So for example, we could be handed a series that has 3 positive terms, 20 negative terms, 2 positive terms, 7 negative terms, 109 positive terms, etc., etc. And it's a lot harder to grapple with what these series might do. And this leads us into the concept of absolute convergence. So what we're going to talk about today is a so-called term of absolute convergence and conditional convergence. And to not give away too much right now from the get-go, absolute convergence is going to give us this very powerful tool that if we can show a series as absolutely convergent, then any assortment of negative signs inside of that series will also result in a convergent series. We're going to do some examples of how to find if a series is absolutely convergent, conditionally convergent, or just straight up divergent. We're going to also introduce another test for convergence and divergence, the so-called ratio test. And this test can be applied for series that have very particular forms. So something where we have like numbers raised to the n. So this would be like, something 2 to the n or 1 over 7 to the n kind of thing. Factorials. If you don't remember what factorials are, there's also going to be a video for how to do factorials and factorials with algebra, as well as the last form was the so-called when we have terms like n to the n. These are all going to be indications of when to use the ratio test for us. And we're going to do some examples using the ratio test. And finally, at the end of this a section in the chapter, a section in the book, or in our class, we're going to talk about basically how to think about absolute versus conditional convergence in a much more formulaic way through a flowchart to kind of give you a very clear understanding about when certain tools are useful and when do we have to rely on other tools as well. So I hope that gives you a clear picture of where we're going to go in class. We're still thinking about convergence and divergence of series, except now we're thinking about series that may have negative terms, but not in any discernible pattern. And we're trying to develop tools to figure out what these series do. So with that, please watch the videos and looking forward to seeing you all in class. Thanks.